Welcome back. The tools and techniques, or the main tools that we use in maintenance, is creating redundancy. How we can create redundancy so that the performance of our equipment is increased. In this video, let's discuss about one technique that is commonly used in maintenance, what we call it redundancy. Let's explain several terminology. The failure rate is the basic unit of measure for reliability. The failure rate in percentage is defined by number of failure divided by number of unit tested multiplied by 100%, of course. And failure rate in number is number of failure divided by number of unit hours operating time. So this is the unit hour operating time. And we also introduce in here the terminology of mean time between failure, which is 1 divided by failure rate of n, or failure rate number. Let's take a look at this simple example. 20 air conditioning unit designed for use in NASA Space Shuttle that operate for 1000 hours. Let's highlight the number in here. And one fail. So one air conditioner fail after 200 hours and another one is fail after 600 hours. So the failure rate in this case is, since we have two components fail, one in here and then one in here, so this is 2 divided by the total component 20. So it is equal, the failure rate in percentage is 10%. And then when we try to calculate the failure rate in number, so we divided number of the equipment fail, that is equal to 2, and then how long the component is in operation. So we should calculate that in total it is expected that 20 air conditioning is operated for 1000 hours. So this is coming from 20 air conditioning multiplied by 1000. So this is 20,000. So 20 multiplied by 1000, 20,000. And this one, since there are two components is fail, one fail after 200 hours. It means their operating hour is only 200 and non-operating hour is 1000 minus 200. So it is equal to 800. And the other component fail at 600. So their non-productive time is 1000 minus by 600. So it is equal to 400. In this case, when we sum up, we have this number. Yeah, we have this number. 1000 and 200, this is non-operating time. So 2 divided by 20,000 minus 1200, so equal this one. When we try to calculate the mean time between failure, so we have this number, so 9.434 hours. Redundancy. What is actually redundancy is? Redundancy is simply providing a backup component. So highlight this one, backup component, to increase the reliability. By this formula, we can understand that the system that is backing up by the component that is backing up by another component will have the higher reliability. For example, if we have the component having the reliability 0.8 and it is backed up by the second component also have the same reliability 0.8, and then in total the reliability will be 0.96. It's much higher than the probability of the component itself. Take a look at the example. In the previous example, we already understand, this example provided in the previous video, that this system, the green one only without the backup in this case, have the reliability in total 0.713. How to increase the reliability of the system? We provide the redundancy, the second component, as a backup for the component number 1 with the reliability 0.9 and component number 2 with the reliability 0.8. And what is the result of this reliability for the system? When we calculate this one, then we have the result that the reliability is increased, becoming 0.94 from 0.713. It's quite a lot increase. Of course, this redundancy will affect the cost. So we should make a trade-off between providing the maintenance cost and the reliability achievement. In discussing about the cost, the traditional view attempts to balance between the preventive and breakdown maintenance costs only. But this approach is typically failed to consider the true total cost of a breakdown. When the equipment or machinery is breakdown, there is a problem of the inventory. We need more inventory to keep in our system so that our system can continuously running without that machine temporarily. Employee morale is also affected when the machinery is frequently breakdown, for example, and then we have a difficulty in managing the schedule. So this cost is actually not considered yet in the traditional view of maintenance costs. So when we plot the maintenance cost, with the x-axis is maintenance commitment and then y-axis is cost. This is the traditional view ones. So we got when the maintenance commitment is higher, the preventive maintenance cost will be also increased linearly. And the breakdown maintenance cost will have the slope and how much the commitment that we should put on is this much at this number at this point. So not so much actually, since we already determined that the maintenance cost from the breakdown is only the breakdown cost, the repair cost only. But when we consider the cost of this is the full cost view, and this is the full cost of the breakdown, we have the quite different curve of preventive maintenance cost, and when we already consider all the full cost of breakdown, including the inventory and then the moral opportunity cost and so on. So we need when we sum up this into total cost, we need the more commitment in maintenance, which is this is much higher commitment is needed to keep the high reliability of the system through maintenance. So thank you so much for joining me in discussing about redundancy, and then in the next video we will discuss about the total productive maintenance. See you again in the next video. Thank you so much for joining me in Learning Operation Management. See you again in the next video.